Okay, so right here we have the train. The train's crossing the railroad track or is on the railroad track, and it's crossing the road with a 30-degree angle, and it's going 25 feet per second. And it's saying that this is happening, and 8 seconds after the train has crossed, the train has gone 200 feet. Now, 5 seconds later, this car is going here at 40 feet per second. And 8 seconds after that, the car will have traveled for 3 seconds. So the length of this side is going to be 120 feet. So at this point right here, we need to know what S is. Now, S is going to be drawn not up to the track, but it's going to be drawn to a point that is directly below the track and perpendicular to the train. And that side's going to be right here at 20 feet. So we're just solving for this S portion of this triangle here. So looking at this, we're going to use the law of cosines to figure out what side S is. So we're going to have S squared equals to 120 squared plus 200 squared minus 2 times 200 times 120. Now, the angle here is not changing. We're fortunate with that. And this angle happens to be 30 degrees. So because this angle is 30 degrees, and it would be times the cosine of 30 degrees, that is the square root of 3 over 2. And it's constant, so it's not going to change. So even when we get to the derivative step, we're not going to have to worry about the cosine of the angle. We're going to treat the cosine of 30 as a constant. Well, these two will go away, so this is what we're left with. So the arithmetic here, S squared is going to equal to doing the arithmetic, we add these two together, we get 54,400, and the arithmetic here leads us to 41,500, and I think it's 69 point, and there are some decimals there, I just did not write them down, but in the end, when we take the square root of that, we get 113.273037. So that's going to be the length of this side right here, this side S. All right, now we're going to use that value in the Pythagorean theorem to figure out what this length is here. I'm sorry, I should not have called this S. S should be this distance right here. So this is going to be, let's just call it X. So I need to change everywhere I have S written, I need to make that X. All right, now from here, S squared is going to equal to 113.2730357 plus 200 squared, or sorry, 20 squared, which would be 400. When we do that arithmetic and take the square root, we get 115.0251304. And this is going to be the side that we care about the rate at which it's moving away. All right, now we've got to start dealing with rates here. So at this point right here, we're going to go back. Well, okay, let's just try this. All right, so this would be X squared plus, and this is against constant, so X squared plus 400 equals S squared. Again, your side X is always changing because this length's always changing. Therefore, it causes S to always change, but this 20 is always constant. So the derivative here is going to be 2x dx dt equals 2s ds dt. 2's go away. Now, X again is this 113.2730357, and it's dx dt, which we don't know right now. And then S is the 115.2730357. And then it's, no, that's wrong. 15.0251304, and it's ds dt. So this is ultimately what we're trying to solve for here. So we're going to have to figure out dx dt first. Well, to get dx dt, we have to go back to the law of cosines and figure out the derivative of this value here. So taking the derivative here, we get 2x dx dt equals, now again, your 120 is constantly changing, so we can't put that in. I'm going to call this A. So it's going to be 2a dA dt plus 2b dB dt minus, now this is again a constant, so it's the square root of 3 times AB. So in the derivative form, it would be the square root of 3 A times dB dt. It's a constant multiplier, square root of 3 times A, and then times the derivative of the second term, and then plus the square root of 3 times B times dA dt. And that's what we're looking at right here. Again, dx dt is the only thing we don't know here. We've just got a good bit of arithmetic to do to get to that result. So sitting here, we've got 2 times 113.2730357 times dx dt equals 2 times A, and again here I'm going to call A 120. So it's 120, so I guess I'm calling this side A, times 120 times dB dt, which is, I mean, it's dA dt, which is 40, plus 2b, and we're going to call that 200, and then it's times dB dt, which is 25, and then it's minus, and go ahead and distribute the minus into this parenthesis here, so it's minus the square root of 3. A is 120, so it's 120 times dB dt, which is 25, and then minus the square root of 3 times 200, and then times dA dt, which is 40. All right, so we've got a lot of arithmetic here. This is going to be 9,600 plus 10,000 minus 5,196.1524 minus 13,856.4064. All right. And all of that is going to be divided by 2 times 113.2730357. So if we do that in our head real quick, we get 547.44 over this product of 2 times 113.273035.7, which is going to give us 2.416467. So that's the rate this side's changing here. So dx dt is going to be 2.416467. All right, now we go back to this step right here. We just saw for dx dt, so it's 113.2730357 times this 2.416467, and we can divide this by the 115.02551304 to get our ds dt. And when we do that arithmetic, we get 2.37965889, and again this would be feet per second. So that's the rate at which the car and the train are separating from each other at that instant.